In this video we're going to look at probability involved in permutations and combinations. The best way to teach this though is just to do two questions. Generally these questions really involve combinations as opposed to permutations. Okay, and just to recap, combinations, the order doesn't matter. Okay, the order that people or objects are chosen doesn't matter. However, permutations, it's all about the order. Right, sample question 1. In class A there are 2 boys and 4 girls, and I've drawn that. The 2 boys are in black, the 4 girls are in red. Class B there are 4 boys and 6 girls, and again I've drawn it. 2 pupils are chosen at random from each class group, so that means I choose 2 people from class A and 2 people from class B. So altogether I'm choosing 4 people. In how many ways can the pupils be selected? Okay, so I have to choose 2 from class A. It doesn't matter what order I choose them, so we're dealing with combinations here. So there are 6 in the class and I have to choose 2. Okay, so that tells me, or that will tell me, how many ways I can choose 2 people from 6. And in class B, I'm choosing 2 people from this time from 10. Okay, and I'm choosing 2 from class A and 2 from class B. So 6 choose 2, multiplied by 10 choose 2 is 675 different ways. Okay, so I can choose 4 people from, well, 2 from class A, 2 from class B in 675 different ways. Right, I'm just going to write this up here because I will need that later on. Okay. The next question, calculate the probability. Now as soon as I see that word probability, means I'm going to have to get an answer between 0 and 1. Okay, so it's not going to be just a normal number. It's going to be it's not going to be a number like this. Okay, it's going to be a number between 0 and 1. So calculate the probability that the 4 chosen consist of 2 boys from class A and 2 girls from class B. Remember, probability, okay, we're going back to second year, probability is total number of outcomes on the bottom, or total number of possible outcomes on the bottom, and on top of the fraction then is number of successful outcomes. Right. Well, we know already that the total number of ways we can choose this class is 675. And now we just have to find out how many different ways we can choose 2 boys from class A and 2 girls from class B. So how many ways can we choose 2 boys from class A? Well, there is only 2 boys and we have to choose 2 of them. And there's 4 boys in class, they're asking for girls, so asking for boys in the first one, so it's 2 choose 2, and they're asking for girls in the second one. Okay, so girls from class B. So there is 6 girls and we have to choose 2 of them. Okay, and that will equal 15 over 675. So there's the probability of choosing 2 boys and 2 girls. The next one. Okay, calculate the probability that 4 pupils are of the same gender. Okay, so we could have 2 boys and 2 girls chosen. Sorry, what was I saying? 2 boys and 2 boys chosen. Or I could have 2 girls and 2 girls. Okay, so just to recap that, I could choose 2 boys from the first class and 2 boys from the second. Or I could choose 2 girls from the first, from class A, and 2 girls from the second. And we're looking for the probability of getting one of the 2 of these. Okay, well, let's find the probability of choosing 2 boys and 2 boys first. Again, the total number of ways to choose it is 675. Let's look at the probability of choosing 2 boys and 2 boys. Well, the first class there's 2 boys in it, and I have to choose 2 of them. And this, 2 boys in the second. Well, there's 4 boys in the second class and I have to choose 2 of them. So that here is dealing with this. R, well, R means plus in probability. And now we're going to deal with the 2 girls and 2 girls. So choosing 2 girls for the first one, or the first class, class A, there's 4 girls, so 4 of them, and I have to choose 2. And then in the next class there's 6 of them, and I have to choose 2. Okay. Just put it in brackets. And the total answer then is 32 over 225. Okay, so if we work out the top, we'll actually get 96, and the bottom is 675, and if we cancel it down, then that's our answer. Okay. Okay, so question 2. A hand of 4 cards is dealt at random from a normal pack of playing cards, and remember there's 52 cards in a normal pack. Okay, so the person has dealt out 4 cards. Find the probability that the hand contains exactly 2 queens. It says find the probability, so our answer is going to be between 0 and 1. Right, 2 queens. Well, first of all, we're going to have total number of ways that 4 cards can be dealt from 52. So it's 52, choose 4. And then the number of ways 2 queens can be dealt. Well, there's 4 queens in the deck. Let's choose 2. Okay, I'm not going to do it for you. Just find out what 4 choose 2 is, find out what 52 choose 4 is, and you'll get your answer. Question 2. 4 spades. Okay, again, total number of ways that the cards can be dealt is 52, choose 4. And how many different ways then can we get 4 spades? Well, there's 13 spades in the deck, and we want to know how many different ways we can choose 4 of them. Again, I'm not going to do it. You'll find out 13, choose 4, and 52, choose 4, and you'll find your answer. Question 3. 4 red cards. Again, total number of ways, 52, choose 4. And 4 red cards have to be chosen from red. Well, there's 26 red cards. Again, we're going to find that out. And question 4. 4 cards of the same suit. Okay. Well, I'll spend a bit of time on this one. 4 cards of the same suit. Well, that can be 4 hearts, or 4 diamonds, or 4 spades, or 4 clubs. Right. Remember, we're thinking R here. Alright. So, here we go. Let's find out the probability of getting 4 hearts. Right. Probability of getting 4 hearts. Well, starting off 52, choose 4. And there is 13 hearts, so 13 hearts, choose 4. Okay, R, plus. Again, the number of different ways that 4 cards can be chosen from 52. And again, there are 13 diamonds, and we have to choose 4 of them. R, and you get the gist of it, 52, choose 4. 13 spades, and we have to choose 4 of them. Plus, and lastly, there's 52, choose 4. And there's 13 clubs, and we choose 4 of them. You work that out and you'll get your answer. Okay, lastly then, we're going to look at finding the probability of an event occurring at least once. Okay, so right, at least once means like once or over. Right, so here's the formula for it. The probability of an event occurring at least once equals 1 minus the probability of the event not occurring at all. Right, if we can learn that, then it's pretty easy. In this question it says find the probability of getting at least 1 tails if I threw a fair coin 4 times. Okay, so to do that I want to find the probability of getting at least 1 tail. So that means the probability of the event 1 tails has to occur at least once. Okay, if it occurs twice, great. 3 times, no problem. All 4 times, that's fine, but it has to occur at least once. So the only way I won't be successful in getting 1 tails is if it doesn't occur at all. So what we do is, and if you look up at this formula here, we go 1 minus the probability of no tails occurring. Okay, so let's find out the probability of no tails. So probability of 0 tails in the 4 throws. Okay. Well, probability of getting not a tail the first time is a half. Okay. If I don't get a tail, I have to get a heads. So that's the probability of a heads coming up. And again, probability of not getting a tails the second time is another half. And probability of not getting a tails the third time is a half. And probability of not getting a tails the fourth time is a half. So the probability of not getting a tails in any of those throws is a half by half, which is a quarter, by half by half, which is a quarter, and another half, which is an eighth, and another half, which is 1/16. Okay, so there is a 1/16 or 1 in 16 chance that I will get 0 tails in 4 throws. So to find the probability that I will get at least 1 tail in 4 throws, I say 1 minus the probability of the event not occurring at all, which is 1/16, and 1 minus 1/16 is 15/60. Okay, thanks guys.